Hi there. Let's take a few minutes and go over the study guide regarding the basics of confidence intervals. So, number one, what we're going to embark on is called statistical inference, which means that we want to be able to say something about a population by using information from random samples. And then we'll use probability structures to give us some idea of how strong our conclusions actually are. So in order to do this, we're going to rely on a number of ideas from our last few units. So notice, the law of large numbers tells us that if we're using a large SRS, the value of the sample mean will be, quote, close to the true population mean. How close can actually be described by using the sampling distribution for X bar. So that sampling distribution has a shape, a center, and a spread that we essentially understand. So its shape is approximately normal by relying upon the central limit theorem. We're looking at a sample size of 50 here, so the central limit theorem applies. The center of the sampling distribution is the actual average IQ for this student population. We would call it mu. This means that the sample mean is an unbiased estimator of mu. And then regarding the spread, we can use the standard deviation of the sampling distribution. That would be 15. We're assuming that we know the population standard deviation divided by the square root of 50. So this turns into a standard deviation of 2.1. Now, one of the most fundamental ideas regarding confidence intervals is this following idea, and it really comes from the 68, 95, 99, 7 rule and a generalization of that. So in 95% of all samples, the sample mean will be within 2 standard deviations of the true average IQ. So if we knew the true average IQ and added and subtracted 4.2 from it, that would be 2 standard deviations, that would capture 95% of all of the possible sample means that we might get. But that's exactly the same as saying in 95% of all samples, mu, the true population mean, will be within 2 standard deviations of the sample mean. So we're basically just turning the logic around. If we take our sample mean and add and subtract 4.2 or 2 standard deviations from that, we will capture mu 95% of the time. So in other words, 95% of the intervals that we build this way would actually contain the true population mu within them. And that's what figure 10.3 involves. If you look at the back of the study guide, that's what question number 7 was describing, was this figure 10.3. This is a pretty important figure, so let's take a look at it just for a moment here. So this is what we're really saying. If we have a population, and if over and over again we pull SRSs out of that population with a size of 50, we're going to get a number of different intervals if we take each mean and add and subtract 4.2 from it. If we repeat this process, each time we're going to get a slightly different interval, but we know that 95% of the intervals that we calculate this way will actually contain the unknown population mean mu. So then, on the back side of the study guide, understand then, this is the actual interval that we calculated using the sample mean of 112 and the standard deviation of 4.2. We got an interval of 107.8 to 116.2. And the way that we would interpret this interval, we would say that we are 95% confident that the unknown mean IQ for all big city university freshmen is between 107.8 and 116.2. Now understand, there are really only 2 things that can occur here. That population mean, mu, is either in this interval or it's not. So either we've calculated one of the 95% of intervals that contain mu, or we happen to have one of the 5% of intervals that doesn't capture mu. We don't know which situation we are in, but we know that we are 95% confident that we've captured the true population mean, in the sense that 95% of the time this method is going to give us a result that actually captures the true population mean.